told that the function of x, which is a ln 2x plus b. We're also told that that function at e is equal to a ln, substituting the x for e, is plus b, and that is equal to 3. That's what we're told. We write this function once again now and say that that is a ln 2e plus b is equal to 3. That equation here is going to be a very important. We'll call it equation A. Now we need to find the derivative, and the derivative of that function above is therefore equal to a over 2x plus b, and we need to multiply it by 2 from inside. That really can be a lot nicer if we just write 2a over 2x plus b. Alright, now we're also told that that particular function at e is equal to e plus b. And that, we're told, is equal to 6 over e. I'll rewrite this equation out here again and separate it. But one thing I can see here is that I just don't like the way that this equation has got a numerator over a denominator and numerator over denominator. So I am going to rearrange this equation to be 2a multiplied by e, and then I'll multiply 6 to e plus b. Now this equation is my second equation, which is really important. So I can highlight my first equation so that we are going to be using that in red, and I'll highlight my second equation that I'm going to be using. Okay, rewriting these two equations again. A ln 2e plus b is equal to 3, and the other one is 2ae, which is equal to 6 times 2e plus b. So what I want you to understand is that we are supposed to be finding the constants a and b. So I'm making them red here, a and b. That's what we're looking for. Not e, because e is a number itself. So the way to solve this is by substitution. So we are going to have to look for a best way to rearrange those a's and b's so that we can substitute, so to isolate them. So if I have a look at a here and I wanted to isolate that all on its own, then I will have to put that ln, all this part, in the denominator under 3. And I don't think I want to do that. It'll make it a little bit complicated. Also, using a b here, if I wanted to isolate that b, because it's already in this bracketed form, that's going to be difficult. Let's go to the next equation here, where I've got this A over here. That's not bad. I could do, let's say that I remove the 2 and I remove the E onto the other side and isolate the A, okay? So here I go. That means A now is going to be equal to 6 2 E. I'll just keep those B's in red over 2 E. It's always nice to see something simplifying, like the 6 and the 2 could be simplified over here. So that looks a lot better. Now we've got A is equal to 3 2E plus B over E. I think we're about ready to start substituting. That A can now be substituted. That whole equation here, let's see if we can substitute it all the way into A. So I'm just going to show you. Let's go from here to that number 1 equation, because that was our number 1 equation and this one was our number 2 equation, okay? So this is going to mean that I can write this down as 3 2E plus B over E multiplied by ln 2E plus B. It's equal to 3. Okay, I know it looks a little bit much, but you'll see it'll be fine. That E that we have down here, okay, can now be rearranged and put to the right over to this side. So here we go. 3E 2E plus B is equal to 3E. Okay, if you're actually able to see that that 3 and that 3 cancels out from both sides, that's excellent. So once more, I'll just keep on rearranging this so you don't have to go through every step this way on your own, but this is just so that you can see what it is that you're doing, okay? ln 2E plus B is equal to E. Okay, now you're probably wondering, how is that going to help me? I don't know what you're doing, but if you actually remember, if you can now see, I'm going to put this into a box over here because this isn't going to be part of it. I want you to understand that when you have x, ln x, that's the same as saying ln x to the x. Now we know by law that that is equal to x. This suggests that x is equal to x. In that case, if I had ln x to the x is equal to e, that would suggest that x is equal to e, which would mean that e is equal to x. Now look at our equation, this one over here, okay, at the top. And what do you see? It's the same form as what I've shown in the box over here. The x is the 2e, okay, that x is 2e plus b. Then we've got ln, then we've got x again 2e plus b, okay. We'll rewrite it in this form, and that means that that should be equal to e. Right, let's go and do that. So in that case, if I rewrite this above equation like this, I'll say that's ln 2e plus b to the power of 2e plus b, okay, is equal to e. So do you remember what I said about that? That means that this, make it yellow, that this is equal to this. So now we can write that E is equal to 2e plus b. So let's have a look where we are. We substituted a here into our first equation, worked it all out, and we found that e is equal to 2e plus b. Now I still have the b in red because remember what I want to know is we want to find a and b. That's really useful because I can now rearrange this for b. So what is b? B is equal to e take away 2e. B is minus e. And e is a number, so we found b. Remember, that's what we wanted to do. We want to find a constant b. We've got one of the constants. Now, things are going to be so much easier. Once we have a b, we just need to substitute that b into one of the equations and find a. I look above and I see which equation would I like to do. Well, you know, any equation that's going to be the simplest equation will be the best equation. I go up and I'm searching and I look, wow, that looks like a really easy equation to find a for. So let's just substitute b in there. So a, in that case, or I'll do it in green now. So a now is equal to 2e plus b, and b is now going to be minus e because we just found that. That's over e. Well, that could not be simpler. 2e minus, let's just try writing it out loud just for the sake of being really, really clear. And that becomes 3. 2e take away e is e, over e cancels out, and our a is a definite equal to 3. So now you have found the two constants.